This is the third of our lessons on time. In it, we look at the various forms of time used in order to cater for longitudes other than Greenwich. As we said earlier, by using an apparent solar day, we have a civil day which is of a constant length of 24 hours, with midday occurring approximately at meridian transit. The Earth therefore rotates one full rotation of 360 degrees with respect to the mean Sun in 24 hours. This is equivalent to rotation of 15 degrees of longitude in 1 hour, or 1 degree of longitude in 4 minutes, or 15 minutes of longitude in 1 minute of time. Local mean time, or LMT, is the time as determined by the mean Sun at an observer's local meridian. The datum for measuring the local time is the local noon, which occurs when the mean Sun is transiting that particular meridian. Here, as an example, the time at longitude 45 east is 1200 hours. Therefore, at 15 degrees an hour, the Earth will have to rotate for another 3 hours until the Greenwich meridian experiences noon. So the LMT at Greenwich must be 9 a.m. And similarly, longitude 90 east, which is 45 degrees further eastward, must have experienced noon 3 hours ago. Therefore its LMT must be 3 o'clock in the afternoon, or 1500 hours. We can therefore convert LMT at one longitude to LMT at another simply by the longitude to time conversion of 15 degrees per hour. Here we see local mean times at various longitudes going eastwards as far as the Greenwich antimeridian. We'll assume that the date at 45 east is the 16th of May. The Earth is at the centre of the diagram. As the scene is Earth-centred, instead of the Earth spinning eastwards, we imagine the Sun moving westwards. At 90 east, the LMT is 1500 hours. The Sun passed over it 3 hours ago. At 135 east, it is 1800 hours. The Sun passed over it 6 hours ago. And at the Greenwich antimeridian, 180 degrees east, the LMT is 2100 hours, still on the 16th of May. Now let's look at the same situation, this time going westwards. The mean Sun will not be overhead for another 3 hours. It must be 0900 hours LMT. But as we said last lesson, the local mean time at Greenwich is the definition of Greenwich Mean Time. So the GMT is also 0900 hours. We now use UTC, which for all practical purposes is the same thing. Continuing westwards, the Sun will not pass over 45 west for another 6 hours, because the change of longitude is 90 degrees. It must therefore be 0600 hours local mean time. And so on, until we get to longitude 135 west. This is 180 degrees west of 45 east, and so the time is 12 hours earlier, which is 0000 hours on the 16th of May, or, if you prefer, 2400 hours on the 15th. If we go a further 45 degrees westwards to the Greenwich antimeridian, we are 3 hours earlier. This takes us to 2100 hours on the 15th of May. But if you remember, it was also 2100 hours on the 16th of May when we counted it forwards, going eastwards. Therefore, local mean time changes date when crossing the Greenwich antimeridian. This is similar to the international date line, which follows the 180-degree meridian for the most part, with a few deviations. However, for LMT calculations, these deviations do not apply. Date changeover always occurs at the 180-degree meridian. The time on both sides of the meridian is 2100 LMT, but the date to the west is 15th of May, and to the east is 16th of May. From the calculations we have just done, we can deduce the rule that applies when crossing the international date line. When crossing from west to east, add 1 day. And when crossing from east to west, subtract 1 day. Local mean time is not used for timekeeping and does not relate to anything we set on a watch because it changes as soon as we change our longitude. However, it is important because we use it as part of the calculation of the time of astronomical phenomena, in particular sunrise, sunset and twilight. We therefore need to know how to convert from LMT at one longitude to LMT at another, and how to convert between LMT and UTC. There are two methods, which are the tables in the Air Almanac and direct division of longitude. We'll start with the use of the tables. The first two columns are headed degrees and hours and minutes. Let's go to 15 degrees. The time beside it is 1 hour and 0 minutes. Now look at 16 degrees. This is 1 hour and 4 minutes. The first two columns go from 0 to 59 degrees. The rest, up to the grey dividing column, cover the remaining whole degrees up to 359. The columns to the right of the vertical divider are headed minutes of longitude and minutes and seconds of time. We know that 1 degree of longitude is 4 minutes. So if you look up 30 seconds of longitude, this corresponds to a time of 2 minutes and no seconds. Let's now do a practical example. We'll convert 137 degrees and 36 minutes of longitude to a difference in local mean time. Start with 137 degrees. What does this equate to? 137 degrees converts to 9 hours and 8 minutes of time. Now look up the 36 minutes. 36 minutes of arc converts to 2 minutes and 24 seconds of time. Adding them together gives you 9 hours, 10 minutes and 24 seconds. In fact, for our purposes, the nearest minute is close enough. The second method is by simple division of the angle by 15, but it is easier if you use a scientific calculator with a degrees, minutes, seconds or DMS facility. The actual buttons to be pressed depend on which particular calculator you have bought. On this example, the DMS button looks like this. You start by entering the degrees. Press 137. Then press the DMS button. This little square appears. Then enter the minutes. Press 36 and then the DMS button. Finally, press divide 15 equals. This is a good deal quicker and easier than the tables, and it means that you can still solve these conversions even if the tables are not included as part of the exam. Now we'll look at some practical examples. We'll find the LMT at longitude 103 degrees and 55 minutes east, which is in Singapore, if the UTC is 0800 hours. Your first step is to convert 103 degrees and 55 minutes of longitude to time difference. You should have got the answer 6 hours, 55 minutes and 40 seconds. We'll call that 6 hours and 56 minutes. The next question is the LMT going to be an earlier or later time than UTC? Look at the diagram. The Earth is spinning eastwards. Does Singapore transit the Sun before or after Greenwich? The answer is obviously before. So the time in Singapore will be later. 0800 hours plus 6 hours 56 minutes gives us a local mean time of 14:56. Note that in the table we have a column for the date, as well as hours and minutes. We do not need to use it for this calculation, but get used to putting it in as a matter of habit, because it is sometimes essential. When working out whether LMT is earlier or later than UTC, you can use the rule longitude west, UTC best, longitude east, UTC least. Another useful rule is that when they're having breakfast in New York, it's lunchtime in London and tea in India. Now we'll do an example of the change of LMT from one longitude to another. In this one, you will see why it is important to have a column for the date. The local mean time at A, longitude 137 degrees and 50 minutes west, is 1812 on the 18th of August. What is the LMT at B, longitude 121 degrees and 12 minutes east? Always lay the problem out in a table and always work through UTC. The first thing to do is to calculate the longitude to time conversion. This is sometimes referred to as the arc to time conversion. You can then work out whether you need to add or subtract to arrive at UTC. When you've done that, click to continue. You should have got that you need to add 9 hours and 11 minutes. This gives you a UTC of 3:23 on the 19th. You can now see why we need the date column. We now need to convert from UTC to LMT at B, which has a longitude of 121 degrees and 12 minutes east. Again, do the calculation and work out whether you need to add or subtract to arrive at LMT for an easterly longitude. You should have got that you need to add 8 hours and 5 minutes. This gives a local mean time at B of 11:28 on the 19th. Now, you may have noticed that this question could have been solved without working through UTC. The total change of longitude from A to B is 259 degrees and 2 minutes, which converts to 17 hours and 16 minutes later than A's LMT. Working through UTC as we did may seem longer, but it is very easy to make a mistake if you take shortcuts, especially if the date changes. Always use a tabular layout and work through UTC. However, LMT is unsuitable for keeping on our watches because it varies, as we have said, with change of longitude. Take the United Kingdom for instance. Suppose that the mean sun is passing over the Greenwich meridian so that the LMT there is 12 noon. This means that it was over Great Yarmouth 7 minutes ago. Its LMT is 12:07. However, the mean sun will not pass over Oxford for another 5 minutes. This makes the LMT at Oxford 11:55. It will not pass over Swansea, which is at 4 west, for another 16 minutes. This makes the LMT at Swansea 11:44. And similarly, we can work out local mean times at Land's End and Londonderry. So, between Great Yarmouth and Londonderry, the LMT is 35 minutes different. We cannot work like this when we have train, coach and airport connections to make. We need a standard time for the whole of the country. For the UK, that standard time is UTC in winter and UTC +1 in summer. Most other countries keep different standard times, and we shall look at that now. Standard time is defined as the official time in a local region adjusted for location round the Earth, established by law or custom. It is up to the government of each country to decide what time difference from UTC to keep. Many world atlases include a map of world standard times, often incorrectly called time zones. A typical example is shown on the screen. Previously, we have considered that the maximum time difference from GMT or UTC is 12 hours. For administrative reasons, some of the groups of islands have chosen a standard time that crosses the 180-degree meridian, resulting in a time difference of 13 hours. This causes the international dateline to deviate from the Greenwich anti-meridian. You can also see that countries with a large longitudinal extent have no option but to subdivide into regions, each with its own standard time. Typical examples are North America and Russia. The Air Almanac contains 3 lists of countries showing their standard times. List 1 tabulates those countries which are mainly to the east of the Greenwich meridian, and are therefore ahead of UTC. The figures shown should be added to UTC to give standard time, and subtracted from standard time to give UTC. This applies to the other tables also. Some large countries are divided into areas having different standard times. For example, Australia. Some countries operate daylight saving time during the summer months. This is indicated by an asterisk alongside the country name. Note that in all cases, daylight saving time is the addition of 1 hour to the standard time during summer months, normally between April and October. List 2 at the top of page 3 shows those countries that keep UTC. This is followed by List 3, which shows those countries, mainly west of Greenwich, which are slow on UTC. We will start with a simple conversion of standard time to LMT. Given the standard time in Nairobi, Kenya, is 15:32 on 10th of June, calculate the LMT in Madrid, Spain. The exact coordinates are shown in the text box. As before, use a tabular layout and always work through UTC. From List 1 of standard times in the Air Almanac, we see that Kenya is 3 hours ahead of UTC. Therefore, the UTC is 12:32 on the 10th of June. The longitude of Madrid is 3 degrees 42 minutes west. So, to convert the UTC just calculated to LMT, we need to use our calculator or go to the Arc to Time page in the Air Almanac. Round the answer to the nearest whole minute. Madrid is west of Greenwich, so GMT is best. Therefore, LMT Madrid is 12:32 minus 15 minutes, which is 12:17 LMT on the 10th of June. Standard time is appropriate for land. What about ships at sea? We'll finish by looking at zone time. At sea, in order to keep the ship's time related to day and night, the clocks are altered by 1 hour for each 15 degrees of longitude change of position. The datum used is the Greenwich meridian, as shown on the screen. The band of longitude, 7.5 degrees either side of the datum, uses UTC as the zone time. From 7.5 degrees east to 22.5 degrees east, the zone time is 1 hour ahead of UTC. From 22.5 degrees east to 37.5 degrees east, the zone time is UTC plus 2 hours, and so on. This division of longitude continues through to 180 degrees. Note that the numerical values for easterly longitudes are negative, as this is the correction to be applied to the zone time in order to calculate UTC. Similarly, westerly zone time values are positive, since the time west of Greenwich is behind UTC. The zones are also given letters, as shown with the UTC zone being Z or Zulu. Thus 1200 GMT is also 1200 Zulu. When approaching 180 degrees longitude in the Eastern Hemisphere, between 172.5 degrees east to 180 degrees, the time difference is shown as minus 12 hours. Whereas from 172.5 degrees west to 180 degrees, the time difference is shown as plus 12 hours. Therefore, as we saw in the lesson on LMT, when travelling from east to west across the 180-degree meridian, subtract 1 day. And when travelling from west to east, add 1 day. Although zone time is used only at sea, the term Zulu time to mean UTC is also used by military forces and by many aviators. Let's summarize this lesson. Local mean time, or LMT, is the time as determined by the mean sun at an observer's local meridian. The datum for measuring the local time is the local noon, which occurs when the mean sun is transiting that particular meridian. It is important because we use it as part of the calculation of the times of sunrise, sunset and twilight. We can solve longitude to time conversions using either the tables or a calculator. This is known as arc to time conversion. When carrying out these conversions, always lay out the working in a table and work through UTC. However, LMT is unsuitable for keeping on our watches because it varies with change of longitude. We therefore keep standard time. Standard time is defined as the official time in a local region, adjusted for location round the Earth, established by law or custom. It is up to the government of each country to decide what time difference from UTC to keep. You must be familiar with the operation of the tables and be able to convert between LMT, UTC and standard time in different countries. The international date line does not always follow the 180-degree longitude line. But if you look up the information from the tables and follow the tabular layout, date changes look after themselves. Finally, there is zone time, which is kept at sea. It has little practical relevance to aviators, but the term Zulu time, meaning UTC, is widely used. This concludes this lesson on time. The next will cover sunrise and sunset.